Bueno, buenas tardes a todos. Muchísimas gracias por venir a nuestro Meetup de los Data Science Spain. Es nuestro 14 Meetup. Como sabéis, ya llevamos casi 2 años con el grupo y os agradecemos que vengáis a estos Meetups porque para nosotros es una oportunidad pues, para compartir lo que es para nosotros el Data Science y tener un contacto con gente que trabaja en el sector. Y la verdad es que este verano teníamos una oportunidad estupenda y es que 2 estudiantes de la Universidad de Columbia han venido a trabajar con nosotros. Ellos son estudiantes del máster de Big Data en la Universidad de Columbia, que es uno de los más prestigiosos que hay a nivel mundial, y no podíamos dejar pasar la oportunidad de que nos cuenten un poco su experiencia, que nos cuenten cuáles son las diferencias entre España y Estados Unidos y un poco cuáles son los perfiles que se demandan en cada país. Y bueno, aparte de eso, si hay alguno que tenga interés en estudiar un máster y que esté pensando en hacerlo en Estados Unidos, especialmente en la Universidad de Columbia, bueno, pues tanto Andrew Saltz como Tianhao Lu están aquí para, bueno, pues para contestar todas las dudas que tengáis. Y bueno, pues cuando acabe el Meetup, como sabéis, normalmente nosotros os ofrecemos un pequeño pisco labis con cervezas y Coca-Cola y bueno, un poco de comida para que podamos un poco intercambiar las impresiones. Y nada, pues muchísimas gracias por venir y os dejo ya con ellos.
Hola. Bueno, vamos a hacerlo en inglés porque Tian no habla español muy bien y yo también no hablo español muy bien. So vamos a hacerlo en inglés. Si hablamos rápido, por favor, pide que paramos y habla más despacio. Bueno, es el visión de Data Science de los Estados Unidos, de Nueva York, de Columbia University. ¿Alguien aquí no conoce Columbia University? Ok, bueno, perfecto. Bueno, esto es Tian, es como Sebastián, para pronunciarlo. Bueno, sorry, let me switch to English now. So just a little bit of background about who we are. Tian worked in machine learning and advertisement before starting the master's program. And strangely enough, he studied film before he went into the master's degree. So you don't have to have you don't have to study computer science, informatica, or physics or math. I studied economics before. He likes graph theory and cocido merengue. Before I got in, and I'm Andrew, but nobody can say my name correctly in Spain, so you can just call me Andres. I was in the insurance industry before the master's program, and I was also a DJ for 15 years. My favorite thing in Spain is when people say this. So if you all say this, it sounds like you're saying this. So say Star Wars. And say them both, and you'll understand what I'm talking about. We're both getting master's degrees at Columbia University. So we're both in the process of pursuing our master's degree. So today what we're going to be talking about is data science in Spain versus US, specifically Madrid versus New York, how it's different, and the skills that are being looked for in the United States because there's such a broad range of skills. The different types of data scientists that are being searched for in the US, as well as the curriculum, the classes that you would take at Columbia if you were getting a master's degree, and how it affects you in industry. So we'll do a little bit of battle between Spain and the United States. So this is just Madrid and New York. There's 3 million people in Madrid and 8 million people in New York. There's your unemployment rate. That's just for Madrid. And we just looked on Indeed this week. Does anyone in here not know Indeed? Indeed is a job aggregator site, so it has all the sites. So we searched just for data science jobs from the last 15 days. We found 500. So basically that means that there's 21 times more demand for data scientists in New York compared to Madrid. It could be because Madrid is not as developed in terms of data science. It could be that Spain's not as developed. There could be a multitude of reasons. It's just maybe a demand issue. But considering that, I'm sure that several years ago it looked like that in New York. So just a few years behind. And I think that has more to do with the businesses rather than the skills. So if you can't find a job, go to New York. So the data science skills that are generally looked for, this is like quite a long list of things, right? The unicorn data scientist that has all these things, they're expecting, you know, like if you guys can see in the background, it's like a Superman, like a superwoman, depending on which way you like. But there really aren't people who can do all of these things. It's very rare to find someone who could do all of these things. So there's really now, based upon the fact that there's not enough people who can have all these skills, data scientists are being broken down into 4 different categories. If you look on Indeed.com, this is about the breakdown. So there's 4 different types of data scientists. There's the more business-oriented data scientist who, you know, they often have an engineering degree. They're leaders and managers. They're the people, you know, the business people that all the data scientists don't think do anything. They like just sit around. That's what they're working on. The creatives are more of your visualization, the data scientists that focus on visualization. They're often doing front-end work, so when you're dealing with apps and interfaces, updating. Does anyone here know how often Amazon updates their front end? ¿Alguien entendí la pregunta? Do you know how often? So the Amazon updates their front end every 11 seconds. So new code is pushed out every 11 seconds. They're constantly running A/B tests. The people that are running those tests are right here. Then you have the engineer. These are the people that are writing software. Most of the people in this category are sitting there doing Python. They're generally your big data people that everyone says here, big data, which, you know, eventually we'll get to like humongous data and ginormous data. They're working in production environments, again, often having a CS degree. And then the researcher, these are people that are coming from the academic world. They have PhDs, they're doing a lot of the financial work, they're building the models, and that's where they come from. That's where the largest demand is right now, at least in New York. One thing that's really important to note, these first 3, because of the new education economy that's coming around, where you can take classes on Coursera, or you can learn a lot of these things on your own, a lot of people don't have degrees. One of my best friends, he's a data scientist, and he never went to college. So if you have the skills, they don't care as long as you can do the job. And that's really the whole idea of the shortage in data scientists is driving this, where people don't have to go get a paper degree from a university like Columbia. So this is sort of a breakdown of the skill set needed for the different types of data scientists to give you an idea. This isn't mine. This is not an original idea of mine. I got this from this gentleman right here, Mr. Harris. But you can see that from the business person, their biggest space is the business skill. The creative has visualization. The engineer is machine learning. And the researcher is statistics. Generally, everybody has that same sort of math, and you can see the programming skills sort of go up. For some researchers, like you guys have heard, like scientists make terrible business people, and business people make terrible scientists. Well, there's proof, sort of. So hopefully that gives you a little bit of idea of the state of the U.S. in terms of business and what type of data scientists they're looking for, as well as the skills you might need to become a data scientist. And now Tian is going to talk a little bit about what Columbia University, in terms of the curriculum and how it applies to industry.
Thanks. Hello? Hello? Yes? Okay, cool. So, just as Andrew said, I don't speak Spanish that well. There are maybe 50 words that I know in Spanish, so I will not humiliate myself, and I'll give the talk in English. I come from a background in advertisements. That's what I spent my first 4 years of my career in, where I work with other data scientists in applying some of the machine learning algorithms, trying to understand the landscape of advertisements before I started this master's degree at Columbia. So for the next part, I'll be mainly talking about you can think of it as a school versus reality thing, especially how things are taught in school in Columbia versus how they are applied in the reality from my observation. So for this master degree in Columbia in data science, there are some things they call core curriculum, which is basically things that every student needs to take. And there are electives, and I'll comment on both. So this is the very basic probability theory that every student needs to know. You can think that these are all the very basic things that are, I think, fundamental to every statistical learning theories. And of course, they're essential to understanding anything more advanced. And after this class, students will take something called statistical inference, which also has a much longer history than machine learning, because it was in the era when people do not have the full data set, so they need to do like hypothesis testing and take a sample pool and those kind of methods. So I think that in reality, people usually do not do that much sampling or, let's say, feature scoring, that kind of traditional statistical inferential method anymore in a lot of machine learning communities. But I think the ideas and the mathematics behind these things are still very, very cool and fundamental to understanding a lot of the more popular, more trendy statistical methods. One of my favorite thing is that it talked about a lot of non-parametric methods in this class, which I think is also becoming more and more popular. And some of the application of the class's content on the industry usage is that, for example, in my previous company, we use logistic regression, which is, I know, a lot of people's favorites, for predicting how likely that an advertisement, when posted on a web page, is likely to get clicked upon. And this is like very traditional binary classification problem, and we collect like millions of features, and we try to reduce and select the number of features that we think are most important. And million features, that sounds like a bit scary, but there are lots of them are just binary features. For example, if this person was in the state of New York City or not, or what time this click happens. So I think the takeaway for me from this experience was that in class, they teach you a lot about the theories, the mathematical things of the models, which are certainly fundamental, but in reality, it's sometimes more important to know a good domain knowledge because, for example, you can do lots of things to understand what features are most important, but someone else who does not have those backgrounds in mathematics, but who has worked in this industry, he or she may have some insights that can save you time in the model selection. He or she may have know that, just by my experience, I think that these features are most important. And from my experience, lots of times those kind of insights are correct. So those two were for the statistics preparation, and of course there's the preparation for the computer science part. So students need to take this class called algorithm in data science, which pretty much just is a very traditional algorithm class with more or less a more emphasis on the data science part. So we start to get an idea of the computational complexity by understanding the sorting, and then some essential graph algorithms, BFS, DFS, and max-min flow. Dynamic programming, which has been there for like 50 years, ever since World War II. Linear programming, which is, I think, one of the coolest ideas ever invented. And we also learn reduction for NP-hard problems, which is more theoretical. So this class, although no one expects you to, I guess, implement a breadth first search in reality anymore, but it's of course nice to know how these things were derived and some of the nice properties of them. And in my own opinion, this class also lays a good foundation for students to understand some more advanced models. So for example, recently I was reading this book by Daphne Collar, She's like one of the experts on probabilistic graphical models at Stanford University. And the book's like very theoretical, but also with applications. And so for most of the book, you just need to have a good understanding of the basic graph algorithms and statistics to follow. But in one chapter, she was talking about why doing a specific kind of inference on a Bayesian network is a NP-hard problem. And then there was a subsection where she explained how you can reduce a 3 SAT problem to that inference problem. So if I had not being exposed to this kind of like theoretical foundations, it will be like impossible for me to follow that section. So this class is really like a nice introduction and a very rigorous preparation for students to get exposed and follow those more advanced models in data science. And of course, this is the class on machine learning, which is I guess 50% of what people talk about data science nowadays. So this class by itself is very, I'll say, theoretical. Usually, they require you have a very good background in linear algebra and calculus, I guess, to read those papers on these different popular methods in machine learning, especially, I guess, supported vector machine, which is still a very popular method in a lot of major machine learning communities. And of course, it has a huge application in industries. I guess the only thing I want to talk about here is that it's, again, a takeaway between the theoretical parts and the reality parts. So, for example, in class, when they teach you about SVM, the important things, I guess, are what kind of kernel function to use, and know the duality, know how to do the Lagrangian multipliers for the derivation. But in reality, it can be more important to know what kind of features might be important and how to select the features and how to clean the data and know the upper bound of how many data samples you can run smoothly on the SVM and how to parallelize certain steps in the SVM. So that's like another example of the theory and the reality. But of course, those two things are constantly mingled with each other, and at least in the States, in the United States, there's like a huge collaboration between the academia and the industrial machine learning community. So another class is on computer systems, which basically prepares students with a basic introduction to the popular parallelism and concurrency models nowadays, such as Hadoop, HDFS, and Spark. I don't think this class prepares students in too much depth because, for example, it will teach you the basic idea, the concept of MapReduce. Students have to read a paper in 2003 when Google first introduced the idea of MapReduce. And then students do something in PySpark, such as word counting, which is like a very standard first practice for understanding how MapReduce works. But there certainly lays a good understanding for students to work on real industrial problems later in their careers. So at Synergic, which is the company that me and Andrew are interning at this summer, the Spark is mainly implemented in Python, but also sometimes in Scala, because Scala is like written as a functional language, and by default, it's like very suitable for implementing the idea of Spark. In my previous company in New York, we were raising how many of you have heard the language closure here? How many have you heard about Lisp? Cool. So that's just another functional language, which I guess to some extent is more functional than Scala, because Scala still like heritages some of the syntaxes from Java, while Clojure is like more of a pure functional language, at least I guess from the view of its syntax. So there are data scientists in the in the United States who are now sort of devoted to implementing Spark on other languages besides the ones on that you can find on their official website, namely Python, Scala, R, and Java, I believe. So this is the last class required for all students. Hello? This is the last class required for all students in this program, data visualization. So this class is a lot more flexible. It doesn't have a standard agenda, and it's not like doing a lot of theories. It's mainly preparing students for using different tools and understanding different kind of charts popular nowadays in making data visualizations. Different instructors will teach you different tools. The one I took mainly uses R. And the industry application is certainly humongous, because I think for data science projects to have a big impact, not only amongst machine learning communities, but also amongst like common audience, maybe without a strong technical background, you want to present some eye candies that catch their attention, but not just something overly with like colorful graphs, but also with a lot of insights. So I think this is what this class is all about. D3 is something that is obviously heavily used in all kinds of data visualization nowadays. Besides that, Tableau and CartoDB, Django, are like some of the other popular choices that I've seen. So that's a wrap up of the core classes that are required for every student in this program. And then, because Columbia is a very huge university and there are a lot of electives that students can take, so here I'm gonna touch upon 4 main categories of electives that students usually take from this program. So the first one are some other classes that students usually take in computer science departments. And I guess these are like all very popular things that if you are working in the machine learning community, these are some things you hear a lot about nowadays. NLP, CV, and deep learning. And there are like tons of applications of these, obviously. And I think not a single topic can be isolated from others. One of the things that is used nowadays is that image classification, for example, on different websites. So this is one of the concrete examples. In my previous job, one of the tasks is to understand what each page is about. So you want to assign a topic to each web page. And of course, there's huge amount of data you can use. The major source is, of course, the text and the words. But pictures on the website is also another thing that's popular, that should be used as information. But of course, retrieving information and doing topic modeling for pictures is a lot harder than topic modeling for words. So we use something like the manifold learning, and we built I think we did TensorFlow for doing image classification after the training. The second big popular department for students to take electives classes in is statistics. So these are some classes that are optional for students. And so I myself am a huge fan of probabilistic graphical models. So one of the models I'm very fond of is, how many have you heard about the latent Dirichlet allocation? Latent Dirichlet allocation. Cool. So essentially, it's a very popular method nowadays when you do text or document clustering. Of course, you can do traditional stuff such as k-means, but this method, which was developed about 10 or 12 years ago by 3 authors at Stanford, is now like a very mainstream thing. I think it's even one of the default models you can use in MLib from Spark. And one of the authors is actually teaching at Columbia on the class called Graphical Models next semester. So it's like a very cool thing to learn the model from the author himself. So the third big category of classes you can take from is operation research. So courses from this department have I guess a mix of technical classes, but also business-oriented classes. So, for example, you can take game theory and see how it interacts with computer science. But you can also take something called entrepreneurship, which prepares students to start their own startups if they want to do that one day. But also it prepares students if they want to do finance engineering, beyond coding in MATLAB. There's just some options. So those three were mainly in the technical focus. However, Columbia does have one of the best business schools in the United States. And just like Andrew was pointing out, business is one of the 4 main category of data scientists nowadays. So if students want to take a class in business and get some more business skills, do they have the option? Yes, they do. These are some of the classes that are popular as electives for students to take in the business school with some MBA students. And I think, again, if you're taking finance or economics classes, that gets you in a better shape if you want to do something with financial technology companies later that are not only requiring to have a solid background in mathematics and machine learning, but also have some key insight into their application in finance. So that could be a good option. But I think also more importantly, to be a good data scientist, it's not only necessary to understand your model and to talk in the machine learning lingos, right? But also be able to explain it in a very easy to follow terminology to audience who are from business or just like other backgrounds, not necessarily with a technical background. From my experience, when you go through slides, more equation on the slides can easily lose people's attention. So how to explain the things without losing the gist, I think is a challenge. And this could be a good preparation. So those are the classes that are mainly in a style where people teach you to do something. And by the end of your graduation, every student needs to finish something called the Capstone Projects. So it is a class, but it's more like a semester-long project sponsored by some of the big-name companies like Facebook and Google and Amazon, that they present a real-life data set and a concrete problem to the students, and then students spend 1 semester in teams to work on this. And so this is a typical workflow of how the semester starts. We do a lot of heavy literature review on the relevant topics, and then we do some model selection. And so those are the paper phase, I guess. And then for the programming phase, that's the time to get our hands dirty. We will do a lot of data wrangling and cleansing. And then finally, after we have our results, we'll do a visualization and presentation phase by the end of the semester. Also, we need to write 2 research-style reports that where we just briefly talk upon what are some of the technical challenges, but also social challenges. For example, maybe it was difficult to get the data, not due to technical reasons, but due to ethical reasons, because that's becoming more and more of a concern in, I think, machine learning and just common communities who might be interested in machine learning. So this slide lists 4 of the past examples that students did in this class, really across different industries. Healthcare, where they use deep learning to detect learned tissues that were damaged. Finance, where they use common filtering to detect some mispriced securities. In the visualization part, to help the government of New York to predict where people might have complaints about too much trash just piling in front of their doors the next morning. Very annoying in New York City if you've been there. And rats. So Synergic Patterns was also one of the sponsors for this class at Columbia. And last semester, students built a recommendation engine, which I think is very cool, so that the engine does a task of recommending cool spots nearby if you're in Spain. So like if you're walking by a street in Madrid, it's gonna tell you based on your past search patterns, these are like the cool bars or music, jazz places, or restaurants that you might be interested within like 3 blocks nearby you. So those are just some examples that students have finished in this Capstone project class. So that's like a brief summary of what kind of courses students take, and some of my own observation on how the theory and the reality differ but also mingle together. And that really sort of wraps up our presentation today. So now it's time for questions and answers. Yes? Pleasure.
Can you tell us a little bit about your own capstone project?
A little bit about...
Sorry. Can you tell us a little bit about your own capstone project?
So neither I nor Andrew have taken that class yet. So those were just like some are hearing from some of the past examples.
It's the last class you'll take after taking all the classes. So generally, the way that it works, it's a little bit different than here in Spain, but you take 3 semesters of school, which a semester is 15 weeks. And it's a total of 10 classes to finish the program, so it's about a year and a half. So once you're taking the last semester, you're taking 2 classes, one of which is the capstone. So neither one of us has done a capstone. But one of our friends did one of my friends did the lung cancer one using deep learning to predict when someone has a disease. It's really interesting to see the work that they had done.
Hello, thank you very much for your insights as well. I just had a question, just on the curriculum from the master you're taking at the moment. Based on your experience, your current experience, where do you think that these studies would take you more into which 4 of the 4 types of data scientists you've talked about?
So I think that really depends on, okay, so for me, I think that depends more on your own backgrounds and what you're interested in than the classes themselves. Because I've taken most of the 6 required classes so far, and they really give you a good foundations for like the must-know things, whether you're going to be like a business data science or like a research kind of data scientist. But then I think it's more of a combination of your own background and maybe some of the elective classes that will really lead you through and to be like the type of like data science that you want to be. So like for example, if you want to be a more of like a data engineer, then you probably want to take some classes in. In such as advanced database system and really know like those SQL operations in theory and in practice. But if you're more interested in becoming like a business consultant kind of data scientist, then I think it's definitely a good idea to take some classes in such as like, negotiation, game theory strategy, that kind of classes.
To add to that, it's not just the classes at Columbia University, because there's a lot of opportunities to get involved in the different communities at the university themselves, at the university itself. Professors are really, really open to meeting students. So business school professors, especially the fact that when people are studying data science, there's partnerships with the history department, with the art department, with the business school, with the medical school. It really allows you to explore whatever avenue you want. And because being in New York City, there's also the complementary ability to work while you're going to school, although it's kind of complicated because it's really, really intense. The workload is really intense at Columbia. I would say if you're going full-time, you're probably working somewhere between 60 to 70 hours a week if you're smart. And if you're not, you're working like 100. So it's really intense, but there's so many opportunities because of where you are. And at the university itself, A lot of the professors there actually work. Some of our professors work at IBM Watson. There are classes that are taught by, I think one of the classes is taught by the head of data science at Google in New York. So there's opportunities depending on what stream you want to go into, not just based on the classes, but also outside of class. And it's really up to you about what you want to do in terms of that path that you want to take towards which one of the data scientists you want to be.
Totalmente. Yes.
Hi. This is a question about the slide you showed about the differences between the posting of jobs in New York versus the ones in Madrid. Okay, there's a difference of about, you mentioned like 20 times more or 30 times more or something. It may be explained because of the platform you use, because it was not so popular in Spain, etc. But on the other hand, it's obvious that there is a gap between what happens nowadays in the States and what's happening in Spain. And our point of view from Spain is that there's like 2 years distance between what's happening right now in New York, for instance, and what happens in Madrid. So what's your perspective? How do you see the future from the point of view of job postings in the area of data science in the next years in the States? Because we might figure out what will happen in the next 4 years if you are capable of predicting what's happening in the States as well.
So I would say that most of the challenges that are driven aren't actually driven by the data science community. It's more of the business community. We don't really hear people saying the words big data anymore, but from what I understand at Synergic, in order to sell to companies, you actually have to say big data to the leaders of businesses. So I don't think it's the level of skill of the data scientists. I actually think it's the level of the skill of the executives at these companies that's driving the problem, driving the challenge here. So part of the reason that it's further ahead is, for example, like the mayor of New York, Michael Bloomberg, invested $40 million into Columbia University opening the Data Science Institute. If you had a mayor here in Spain investing that amount of money into data science, and there was a partnership with the business community, and it was someone at the level of Michael Bloomberg, you might see more of an explosion. Michael Bloomberg really sort of helped drive technology in New York City, and so that might be why we're seeing such a huge uptake of jobs. There's also a really big demand, and there's a lot of opportunities to learn, not just at the university level, but there's non-university education systems, not even talking about online. So if you're projecting the next few years, I think what we're going to see, so just to give you an example of what happened at Columbia, last year there were 700 applications and 90 students accepted. That was the year that Tian and I started. This year there were 2,100 applications and 90 students accepted. So we're going to see the supply increase. I think that whole sexiest job of the 21st century type of thing sort of drove it. The job market, the fact that there's all these technical jobs. You'll see a huge growth, and I think it'll equal out over time. And I think from a Spain perspective, it's more about the leaders and the executives, not even the top leadership, but middle management as well, being educated and getting more of a culture of data science. If you think about it in terms of the companies, the way that they're sort of transforming, the taxi industry, is trying to jump on the Uber bandwagon, but Uber is not a taxi company. They're a technology company that has their DNA has data science in it. And until companies start thinking of themselves in terms of having data-driven decisions as part of their DNA, you're not going to see the transformation. There are some companies that are doing it. There's some companies that recognize it. I think Telefonica recognizes it. I think some of the clients of Synergic are starting to recognize it, but it's also changing the culture, not just at the higher level, but on the way down as well. Did I answer your question? I can't. Yeah, I don't think I never make predictions because I'm always wrong. That's why I never gamble. It never works. Yeah, but if I do that, then I'm still doing it wrong.
Yes.
So you gave us your vision on the differences between both places, but how does it feel like to be working right now in data science desert or something like that? I mean, Madrid. From the point, I mean, you're coming from this place where there's all those interactions between huge number of people, huge communities, huge interactions between these communities and a lot of other communities. So how does it feel like to be working in Madrid, in a place that, from the numbers the figures you showed, seems to be like data science desert?
So obviously I can only comment from my own experience, but I think the key difference is in Madrid. Okay, so in United States, especially cities like New York or Silicon Valley, there's a big culture for non-technical people to get interested and motivated to pick up the technical skills and really form a data science community. For example, in my last job, the UI designer who was working there, she came from a architecture background. So she studied architecture in college, but then after she joined the company at the startup, she got interested in not only using Photoshop to do things, but also using HTML and JavaScript to do things. So, and there's a huge support for people like her to pursue that kind of things, both from resources within the company, but also resources such as a Meetup within New York City. So that kind of like culture really encourages people to, if they're interested, to get their hands dirty and start learning step by step to pick up these skills. So she's now working as a chief UI designer, and she's like refreshing statistics, so maybe she'll become a data scientist. So here in Madrid, what I observed is that people who come from a strictly technical background, for example, if you have a PhD in CS or physics, I don't think there's like any lagging behind in terms of skills or exposure to the most trendy algorithms between Spain and New York City in terms of if you come from technical backgrounds. However, if you're from a non-technical background, I don't see, at least so far, I don't see a huge support for business people or for support for these people to get involved in that community. So I think that really might be one of the reasons why, back to your point, the notion of data scientist deserts, that's like that people may observe here. So, and again, from my observation, I think one of the solution or maybe something to do to enhance the situation could be to motivate the startup culture, because when you're in a startup with very few employees, the communication cost is like so much smaller than when you're inside the company like McKinsey or Google. So have more startups, have more companies funded by venture capitals and things like that here in Spain. I think that will definitely enhance the situation and really strengthen the machine learning and data science communities here. Answer your question?
I have something I'd like to add. So I think when you're talking about the sort of the desert, I think part of it is the culture of Spain. When I first got here, one of the first few things I heard was that here in Spain, people they work to live, they don't live to work. It's a very different mentality, at least in New York City, where people are working 16 hours a day, and that's their life, right? Here, it's very, very different. And so part of the reason I brought back this slide was because of this part right here. What Tian was saying, people will educate themselves. They'll spend their nights learning about data science in a way that I don't see here, but I mean, I don't follow people home, so I don't know what people are doing after work. But it seems like we're all going out for beers and drinks, and which is great. I'm happy to. I love that, but it's very, very different culture. And I think that in Silicon Valley, I think I heard somebody say this, that they were living in New York, and then they moved to Silicon Valley for a little bit, and they had to leave because they were standing in a bathroom, and two people next to them at the stall were talking about like some algorithm in the bathroom, and they're like, that's all they talk about there. So it's a different sort of culture in that regard. And I really do think that the culture is driven, just like what Tian was saying about having a culture around it, having a community that expands, and then also recognizing that people don't necessarily have to have a degree, like what Tian was saying, in like informatica or math, or some of the best data scientists don't come from a statistics background. They come from, economics background, or they come from an art background, because then you can start thinking about data science through another lens. If you have exclusively, it's sort of like, the community is not, one thing that I like about Synergic Partners, but if you look in this room, there's 4 women in the room and the rest are all guys. Like Synergic has probably maybe 35, 40%. That diversity of people, the diversity of of the different types of people, not just the type of people, but also the background of individuals, is really helps transform the community as well. So I think that that's what could help change it, recognizing that data science doesn't need to come from math and statistics and computer science.
So, thank you. That really answers my question, but it begs another question. What you're saying seems to imply the possibility that maybe it's not just a question of a 2 years gap, but that maybe there's another set of differences between the culture in Madrid or Spain and the US that will not be bridged in 2 years.
No, I don't think so. But I think that the issue is also, we're comparing like Madrid to New York, and they're very, very different cities. If you were comparing Madrid to like Miami, you might have it'd be a better comparison. Not because of the Spanish culture, but because, I'm from Miami, but I'm talking about in sort of the culture of not living to work, right? So, and there are probably people here who do, but it's just a culture of the country, and at least in Madrid, I can't speak for any other cities. So yeah, maybe it won't change in 2 years, or maybe it will, just influencing the culture of where you work, and sort of making, it's hard, right? Culture changes are really hard, so.
And maybe not comparing with Madrid, but do you have any experience with other big technological centers in Europe? Well, I'm saying big technological centers.
London and New York they're not the same, but they're much closer than Madrid and New York. By the way, there's not an insult to Madrid. I love it here. Like, I love this city.
Okay, so they already brought the subject of the job market and the data science ecosystem, the contrast between New York and Madrid. But I wanted to take it from an innovation and scientific perspective, because you talked here about graphical models or dynamic programming, reinforcement learning and all that stuff that is known that is not applied so many times in industry, because there are not so many exotic problems as such. And how do you see the contrast between the innovation and science and advanced science in data science between New York and Spain?
I was following everything you said, but could you please repeat your question again?
Yes. I was asking if you see any contrast between the innovation, the science between machine learning in New York and Spain.
Yes.
Maybe in Spain we don't do as much innovation from a scientific perspective as in New York, or I don't know.
So again, honestly, I do not know much about the academia world here in Spain, because so far my exposure to data science in Spain has been exclusively through my work. But I do think that in New York City, it's in my experience, it's relatively easy to come up with ideas, because for a couple of reasons. A, because it has some of the best schools in data science and statistics, for example, Columbia and New York University. And also it has a very strong and robust knowledge sharing culture. So I'll give you a concrete example here. Last year, I joined a meetup called the Math and Algorithm Reading Group. So that's like probably the most geeky meetup group I've ever been to. And for 3 months in a row, we meet every week, and we read this book on information theory chapter by chapter. So we started with the classic paper by Shannon in 1948 on the mathematical communication theory, and then we finished that book, and then we started to do more something on causal inference by Julie Pearl. So as you said, even in the United States, causal inference is something that maybe only 5% of the companies out there will even touch upon or think how to implement on big problems. But there's like a very robust community there. And if you want to find someone to talk to, it's easy to find someone to talk to, and it's easy to find someone who's an expert on this topic. And it's easy to find someone who can share a lot more excellent resources on these things with you. Again, to Spain, I really don't know that much about how things are developed here. Another thing I want to talk about is the language, because English is the dominant language in most of the world top-notch academic conference nowadays, and I think that can sometimes be an obstacle for researchers and really talented scholars from countries that do not use English as their main language. I'm not saying that's exclusive to Spain, but just from my observations, sometimes that can induce a bigger communication cost for people from the English-speaking world and the non-English-speaking world. If that answers your question. Yeah. Thanks.
Just to add to that, the second most common language that papers or data science papers are written in is in Spanish. So, I mean, there you go. So, it's not that far behind.
Yeah, I didn't mean about the language. I mean about how it's actually applied in the industry, the science and technology. As you said, there can be meetups and all that stuff, but it's sometimes maybe frustrating that it's not that so much science that is very interesting is not actually applied to industry because there are not so many problems. I was just stating that fact.
There aren't very many professors at Columbia, at least in the data science department, that are working on anything beyond theoretical solutions. They're all very, very focused on theory, with the exception of probably one or two. They're all really, really, really focused on theory in data science. There aren't, when you talk about like applied courses, all the applied courses are electives, and anybody teaching the main courses are all studying theory when you have a conversation with them. So there are some connections, but just like Tian said, it's more in the sort of the meetup space or expertise that are paid to come in as consultants.
Okay, thanks.
Hi. Yeah, so we usually take part in data science competitions like Kaggle. And in Kaggle, usually to win, if it is a structured data, it's always a gradient boosting machine algorithm, usually XGBoost. And I see here in the machine learning slide that you cover the typical k nearest neighbors, regression, etc. I was surprised as a machine learning practitioner. I don't have the slide in front. Oh. So super vector machines, so the classical ones, but like you would never win in Kaggle structured data competition with these algorithms. So I know that, I mean, I'm sure that Columbia is not outdated, but how do I join this? Like, in order to win, you use something, and then I don't see too much focus on Columbia on this.
Sorry, just to confirm, I'm understanding your question. You're saying that you see a lot of Kaggle competitions out there, and you see people win with this or that algorithm, but you do not.
Specifically with gradient boosting machine, and specifically with an algorithm called XGBoost.
It's called what?
XGBoost. That's the name of the algorithm.
XGBoost.
It's a specific type of gradient of GBM.
Oh, okay. And you see people win with this
always.
Yes.
Always. Every time it's structured data, you win with that. And my question was, I see, like, more like a broad spectrum, and my question is, you would never win with with this.
That's a really interesting question. Okay, so.
This is an introductory course into machine learning.
Okay.
So if you wanted to go into more This is an introductory course into machine learning. If you wanted to go more advanced, you would go into the electives and you do some deep learning classes. There's an advanced machine learning course. So this is basically, because we touched upon the skills earlier, it's to make sure that people have like a solid foundation about these topics, or actually these topics. So you have a foundation, and then you can explore, like we were saying about the question earlier, you can explore the subjects that you're really interested in. So if you're really interested in machine learning and you wanted to become one of these, you wanted to become more like an engineering side of data scientists, you would focus on that in your studies. So there are people teaching those things. And I think that in the machine learning class, I haven't taken it yet, that you do you have to do a Kaggle competition in the class itself. Although it's just specifically for the class, like who's gonna win in the class, right? But yeah, they do teach that crazy, even stuff beyond what you're talking about that I don't even know how to pronounce because the names are German or something. Does that answer your question?
Yeah, great, thank you.
¿Alguna pregunta más? ¿No? Bueno, pues muchísimas gracias a Andrew y a Tian por compartir con nosotros su experiencia y su visión sobre la ciencia de datos. Y bueno, hay un dato que os ha llamado mucho la atención, que he visto que preguntabais bastante ahora en la ronda de preguntas, y es el 8 versus los 500 puestos de trabajo que se ofertan. Entonces, bueno, nosotros desde Synergy, que en este momento estamos reclutando a bastante gente, así que si tenéis interés en trabajar con gente como Andrew, con Tian, o estáis interesados en la empresa, Carla Martínez, que es nuestra directora de estrategia, está aquí para que podáis hablar con ella, de verdad, acercaros con total libertad, si es tanto para vosotros como para cualquier otra persona que conozcáis que está interesada en trabajar en una empresa que se dedica a la ciencia de datos. Y nada, por nuestra parte, muchísimas gracias por venir con esta ola de calor que había y esperamos que hayáis disfrutado y sobre todo que hayáis aprendido.
Thank you.